in the last three examples, we looked at a specific vector space. We looked at vectors, we looked at matrices, and we looked at functions and proved that a subset of each one was a vector space on its own by proving it's a subspace of the bigger one. Now, in this example, we'll be starting with an abstract vector space. We don't know anything about V except that the fact that it is a vector space. And I'll prove that it has two subspaces at least. So I'll prove first that this set with only the zero vector is a subspace of V. I'll use the three properties here, and then I'll prove that V itself is the subspace of V. I'll be using the definition here. I'll explain why. All right, so let's prove the three property. 0V is in W. Yes, in fact, it's the only element of W. If I take W1 and W2 in W, while W1 is 0V, W2 is 0V. It's the only element we have. And so if I add them, well, if I add 0 to 0, I get 0, which is also in W. Check. Third, I'm going to take W, well, it has to be 0V, and K in R. K times W is K times 0V, which is 0V, which is in W. And so since all three properties are true, that implies that W is a subspace. So the zero subspace contains only the zero element. All right, second, V is the subspace of V. I could prove all three properties. That'd be longer than doing what I'll do. I'll go back in time and look at the definition here. W be any subset. W is called a subspace if W is a vector space under the addition and the scalar multiplication of V. So in this case, going back to the definition is actually faster than using the three properties. Because all we have to check is that V is a subset of V, and V is a subspace, is a vector space, sorry. With the operations of V. Well, that comes from the hypothesis here. We're giving that V is any subspace, is any vector space, and so this V, the smaller one, which is actually the same size, is a vector space. And so by the definition of subspace, V is a subspace. All right, so because all the elements of V are in V, and because V is a vector space on its own, while V is a vector space inside V, so V is a subspace. That's all it means, really.